Hi, welcome to Mathematics with Tom. I am Tom, and today we are going to make a review of integration by parts. Integration by parts. So what this says is this. It says suppose we have two functions. Let me grab my pen, not the eraser. Let u and v, and you could have used f and g, but it's traditionally written with u and v. So let u and v be functions of x. So you could really think of them as, we'll put i.e. u of x and v of x. However, are often just left as u and v. And the idea is this. It says integration by parts is all about trying to figure out the integral of the product of functions. So let's do that. Let's take u and multiply it by, oops, that's a funny u times v, and let's take the derivative of those with respect to x. Well, that's going to be, it's the first, so u times the derivative of the second. Well, that's going to be the derivative of v with respect to x, plus then we're going to have the second, that's v, times the derivative of the first. So that's going to be du dx. Okay, so, well, now we know the answer here. We know the antiderivative of du dx, of the derivative of uv is uv. But what happens on the right-hand side is of interest. So let's integrate both sides. If I integrate both sides of the function, integral of d dx of u times v dx equals, and we're going to take the integral of the right-hand side, but remember the integral of a sum is a sum of the integrals. So I can write this as the integral of u dv dx plus the integral of v du dx. Now what we do is let's just subtract. You could pick either term. I'm going to subtract the second one. And now let's clean this up. On the right-hand side, the integral of the derivative, that's just u times v. And then I'm going to bring that second term on the right-hand side over. So minus the integral of v times du dx is equal to the integral of u dv dx. And it's commonly written the other way around as the integral of u times dv dx is equal to uv minus the integral of v times du dx. Now, we tend to get a little lazy and instead of writing the formal notation like I just did here, you'll often see it in shorthand of the integral of u dv is equal to uv minus the integral of v du. And that's, I think, kind of the shorthand way to remember this. So that's how it works, or that's where it comes from. Let's try an example. Is, I'm going to call it I. We're going to integrate I. And let's do this. Let's call I the integral. We'll just take an indefinite integral of x times e to the x dx. It seems like such a simple problem. And it is now that we have this tool, but before that, we can't solve this. So here's what we do. We set this problem up in the form that what I have on my right-hand side is this is the idea of this is the integral of some function u times some function that's the derivative of another function, v. That's what I have here. So in this case, I'm going to say, and you can switch these around, I'm going to say that u is my function of x, and that e to the x is the dv. So the derivative of v with respect to x, we just aren't writing it, is e to the x. Well, now what we need is we also need the derivative of u with respect to x, and we don't write it, we just write it as dx on the other side. So we say du equals dx. We take the derivative of both sides, and we want to get v. Well, v is the integral of e to the x. Well, that's just e to the x. That was a nice one. And we just use the general. We'll pick up our constant soon. Now, if I follow my formula, it says that I is equal to u times v. Well, u is x, v is e to the x, minus the integral of v. Well, v is e to the x, and du is dx. So then if I integrate this, I have x, e to the x, minus, and then the integral of e to the x is e to the x, plus I have some constant of integration. And that is how we use integration by parts to solve the integral of a product when substitution won't do the job. I always remembered it as the integral of u dv is equal to uv minus v du. Say it 5 times fast and it kind of starts to roll off the tongue. I hope that helps. Thanks for watching.